Today I'll discuss a scheme for obtaining point groups of objects or molecules. The scheme starts with this question: does the object have multiple high order axes of rotation? High order axis means that in Cn this n is greater than 2, and multiple means more than 1 in number. If the object is of this type, having multiple high order axes of rotation, then the answer is yes, and the special group, the object belongs to special groups like tetrahedral, octahedral, etc. And if the answer is no, next question is the object linear? Does it contain a C infinity axis? If yes, then the next question is, does the object have a sigma h plane? Sigma h means a horizontal plane perpendicular to the line which indicates that the object is linear. If such a plane exists, answer is yes, and the point group is D infinity H. And if no such plane exists, the point group is C infinity V. And here, if the object is non-linear, there is no C infinity axis, then the question is there any Cn axis with n having a finite value? If the answer is yes, then the next question is, are there n number of C2 axes perpendicular to this Cn? If the answer is yes, then the object belongs to D-type point group. And here, if the answer is no, then no, there may be three possible cases. The object may have only identity. The point group is then C1. It may have only identity and a reflection symmetry. The point group is CS, and it may have only E and an inversion center. Then the point group is CI. Now here, if this answer is no, that means that a Cn axis exists, but there is no C2 axis perpendicular to that Cn. Then the object belongs to either a C-type point group, or the point group may be S to N. Now, the next question in both the cases is sigma H present? Here also sigma H present. If sigma H is present, in this case, the answer is yes. Not here. If the answer is yes, then it is of D type, and there is a sigma H plane. The point group will be DNH. It has NC2. It has a Cn axis, then NC2 perpendicular to Cn, then sigma H. Therefore, the point group is DNH. And if here the answer is no, then next question is, does the object have sigma vertical plane? If the answer is yes, then the point group is DND, not DNV. It is DND. And if no sigma V exists, then the point group is simply Dn. Here, if a sigma H exists, the answer is yes, then the point group is CNH. And if sigma H does not exist, then the next question is, does the object have a vertical plane, sigma V? If the answer is yes, then Cn exists, no C2 perpendicular to Cn, no sigma H, then a sigma V plane. The point group will be CNV. And here, if the answer is no, then you have to search for an improper rotation axis of even order. Does the object have S2n axis? If yes, then the point group is S2n. And if no, then the point group is Cn. This is the overall scheme. Here one point is to be noted. Sigma H has priority over sigma V. Sigma H is to be searched for first, and then sigma V. Never search for any sigma V plane earlier than sigma H. This rule has to be followed. And in fact, this is a kind of hierarchy. This scheme has to be strictly followed in order to get the correct point group of an object. I will take some simple examples. Consider a cube. It has the cube diagonals. Cube diagonals are C3 axis, high order axis. They are 4 in number. Therefore, it is of a special point group. I will discuss it later. Let us consider a simple molecule, H2O. It does not have such multiple axes. It is non-linear, and it has one two-fold axis of symmetry. And there is no other C2 axis perpendicular to this C2. Then next question is sigma H. Sigma H is not present. There are sigma V planes. This is one sigma V plane. The molecular plane is one sigma V plane. It contains C2, and this is another sigma V plane. So there is the identity of the object. There are two C2. There is one C2 axis and two sigma V planes. Therefore, the point group should be C2 principal. This number is 2, C2V. The point group of water molecule is this. And if you replace one hydrogen by one chlorine, the system is HOCl, hypochlorous acid. What is the point group in this case? This axis is lost. There is no C2 axis, but the molecular plane acts as a plane of symmetry. So this object has only identity and sigma, reflection plane. So the point group is CS. These are some simple examples. I will consider more examples with complicated structures in my later videos. Thank you very much for watching this video.